Hello, grade 8 math. This is lesson 4.8, volume of a right cylinder. What we're going to do today is figure out how do we figure out the space that this cylinder, so this shape here, a cylinder, takes up, the space it takes up. We're not talking about the surface area this time. We're talking about the volume, which is the space that shape takes up. And what we're doing today is we're going to take our formulas and what we know about rectangular prisms and right triangular prisms and apply it to figure out how to calculate the volume of a cylinder. And we're going to follow a little pattern to do so. So let's see if we can notice this pattern. Before we start, I want to mention that sometimes in these formulas, length and height get switched. And in this case, the most common way that we've seen this rectangular prism, its formula, is length times width times height, so the opposite order of this. And often we talk about area as length times width. But in this case, how this is drawn is this is how tall it is, so that's why I've called it height. And then this long way going back here, I've called length. So sometimes these get switched around, especially length and height in the formulas. And it kind of just depends on how it's set up. So for example, over here, this is the length, and you know what, there could be a height of this cylinder, and all I can do to explain this is sometimes you have it sitting down like this, and other times you might have it sitting upright. And so then what we call things and the variable we use switches. So don't get confused if sometime you see that, oh, this is length times width times height, you'll still get to the same answer. And here, sometimes it might be length here, and over here would be height. Don't get that mixed up too much, because as long as within a question you keep those consistent, it'll still work out. As long as you assign those variables and you stick with it, it'll work. So let's look at this rectangular prism. We know that it's length times width times height to get the volume of the rectangular prism. Nice and easy, just multiply three numbers and it's a cubed unit. But I want you to notice something. If we look at the base of this, so we're talking just this shape here that this is named after, so its name, the rectangle. We look at this rectangle here, this one that's shaded blue. That we could figure out the area. How? By going height times width, right? And if we look in our formula, we have height times width. So that height times width right there is the same thing as the area of that rectangle. And you'll notice that our height times our width, that area of that rectangle, we just multiply it by the length of this shape, this length right here. And that's what gives us the volume. In the same way, look at our formula for the volume of our triangular prism. This right here is our height of our triangle, height, right? Times our base, we sometimes call it. We sometimes use B, but in this case I'm going to use W for width. The variable I choose doesn't really matter too much. So width, and then we divide it by 2. Why? Because this is a triangle. What is h times width divided by 2? Well, that is the area of a triangle. This blue triangle here, the area of it, that two-dimensional space right there, is height times that width, or the base, is what we sometimes called it before, and we divide it by 2. So notice here, for a triangular prism, the volume is found by going area of the triangle times length, and the volume of a rectangular prism is the area of the rectangle times length. And why this works is, if you think about it, it's like there's a rectangle, and how many times you copy it and take up more space and more space as you move back? Well, it's the same as whatever the length is. So the times you do it, remember times means multiply. The number of times you do it is the times the length. That's why we multiply or times it by the length. We take that area and we multiply it by the length. Same way here, we take the area calculation and we multiply it by the length. The same thing is true. Think about this. Both the right rectangular prisms and the right triangular prisms take their base, so that thing they're named after, the triangle's area or the rectangle's area, their name or their base shape, and multiply by their length. So that length that they have there, they multiply by it. So too with cylinders, it works the same. Cylinders and all other right polyhedrons as well. For example, here we have a hexagonal prism. In the same way, if we get the area of this hexagon, this six-sided shape, and we multiply it by the depth of it or the length of it, depending how you look at it, you take that area and multiply by it, you would find the volume of this shape too. It works for all polyhedrons. You take that base shape, the one that I've colored in blue, and you multiply it. So too with cylinders. So we need to think, okay, so the area of that circle is going to multiply by the length of the cylinder. And if we do that, we will figure out the volume of our cylinder. So then we need to think, well, what is the area of this circle? Well, we remember that area is pi times r, also known as pi r squared. So if that's true, then where we have this area in this formula here, area times length is volume of a cylinder, we can take the area of a cylinder and multiply it by length and make the volume. So then we end up with that formula. So often, in question 4 of your assignment, the first question, you're going to use one of these formulas on the bottom, and then the one on the top here is what you'll use for most others. If they tell you what the area is, you just use the one that has area. If it tells you what the radius and the length is, you'll use this top one. Let's do an example. It says here, find the volume. So volume, we're going to use what we're learning today. The volume of a cylinder, okay, so it's going to be this third formula where it's pi r squared times L, with the diameter of 7 centimeters and the length of 10 centimeters. So let's get in the habit of writing down what our variables are. So diameter, we use lowercase d, is equal to what? 7 centimeters, so we know that. And we know also the length is 10 centimeters. So it could look something like this, a cylinder here, and the diameter across is 7, and then the length is 10. And we know that the volume of a cylinder is pi times r times L, also known as pi r squared times L. But we didn't know, they didn't tell us the radius, that r. They told us the L, and we know pi is 3.14 and a bunch of decimals after that. But we didn't get told r. So what we need to do is calculate r, and if you remember, r, the radius, halfway across, is just half the length of the diameter, which is all the way across. So if you take the diameter and divide by 2, you find out the radius is 3.5 centimeters. So put in our numbers. Pi is 3.14. R squared is 3.5 times 3.5. So we do that twice. That's what the 2 in the error means. And then times the length, and the length is 10, so it's 10. So this ends up equaling, if you go in your calculator, or maybe you're good in your head with this, you go 3.14, or you can type pi times 3.5 times 3.5 times 10. You'll end up with 384.8451 and a bunch more decimals, centimeters cubed. Why is it centimeters cubed? Well, because it's three-dimensional space. We're talking about the space it takes up. But also, we have 1, 2, 3 centimeters being multiplied. And when they're being multiplied by each other, we count them, and that's what goes in the air. So it's a cubed unit or a cubic unit. And then to simplify to ones place, because that's usually what we do on our assignments, we round this up. Why? Because 8 tells the 4 to get bigger, so it becomes a 5. 385 centimeters cubed. And that is a volume. That's actually the last lesson in this unit.